So let's go ahead and take a look at this chart here that is in your booklet, and what I'm going to do is I'm going to cross out a couple columns that you do not need to worry about. And so the first column that you do not need to worry about is the electron geometry, and so let's go ahead and cross out that column there. So you will not need to know the electron geometry. The second column that I'm going to have you cross out, which I don't want you to actually cross it out, but what I'll say is you do not need to specifically know this, but it is kind of helpful though to help understand the geometry. Is I'm going to go ahead and circle it though as one that you do not necessarily need to know, and it's this column right here. You don't necessarily need to know the bond angles, although the bond angles do help with understanding the shape that the molecules make three-dimensionally. What you will need to know though is you will need to know the molecular geometry. And you'll see that everything that's highlighted there are ones that you will see in this particular class. And so you have linear, trigonal planar, bent, tetrahedral, trigonal pyramidal, then you have trigonal bipyramidal, and octahedral. What I'll say is these last ones here are really, if you ever see anything that's like SF6, so anything that has 6 atoms on it, it's going to be an octahedral. Anything that's going to be like PCl5, so if it has a 5, that's going to be trigonal bipyramidal. The way I remember that is trigonal sounds like 3, bi sounds like 2, 3 plus 2 is 5. And so trigonal 3 by 2, so trigonal bipyramidal is 5 elements, or 5 terminal atoms there. So that's kind of how I remember it. Remember the difference between linear and bent is that there's a lone pair on the central atom that pushes it down. The difference between trigonal planar, which is this one, and trigonal pyramidal, again, is a lone pair. And so we have our trigonal planar here, which is flat, and we have a trigonal pyramidal, which pushes the bonded pairs down. So something to keep in mind. And then tetrahedral has 4 atoms on it. So for example, CH4, tetra kind of sounds like 4. So that's how I kind of remember those. All right, so let's go ahead and do a couple of guided practice problems here. So you can totally draw the Lewis structure. And for these guided practice problems, we're not going to do the electron geometry. We won't worry about that. But there's actually something that's going to be simple that you can do to determine the shape. And so the first thing you want to ask yourself is how many atoms are on the central atom. In this first one here, there's 2 atoms on the central atom. And so what are the possibilities that it can be? Well, it can either be linear or bent. Those are our 2 possibilities. So it's going to be one of those 2. Well, how do we determine if it's linear or bent? Well, again, if it's got lone pairs on the central atom, it's going to be bent. It's going to bend the atoms down. And so you have to ask yourself, well, does the central atom have lone pairs? And carbon does not have lone pairs. And so this is going to end up being linear. So this is going to be linear. And the Lewis structure is going to look like this. It's going to be double bonds with the oxygen. Oxygen makes 2 bonds. Carbon makes 4, so it works out. It's going to be linear. All right, next one. This BF3, there's 3 fluorines on the central atom. All right, so there's, again, 2 possibilities. It's either going to be trigonal planar or trigonal pyramidal. And the difference between the 2 is whether or not the central atom has lone pairs. If the central atom has lone pairs, it's going to be trigonal pyramidal. If it does not have lone pairs, it'll be trigonal planar. And again, we want to think about what the lone pairs do. The lone pairs sort of push the bonded pairs down. And so we have to ask yourself, does boron have lone pairs? The answer is no, it does not. So it's going to be trigonal planar. It's going to be trigonal planar. And so the Lewis structure here, so we have boron, fluorine, 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 bond, 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 and then put the lone pairs on fluorine. All right, so next one, oxygen is the central atom, and there's two hydrogens. Again, if there's two atoms attached to the central atom, there's only two possibilities. It's either linear or it's bent. So it's linear or it's bent. If there's no lone pairs on the central atom, again, it's going to be linear. But if you were to add lone pairs on the central atom, that pushes the bonded pairs down, making it bent. So the thing we want to ask ourselves is, does oxygen have lone pairs? And it turns out that it does. So what ends up happening is it's not linear, and it ends up being bent because there's lone pairs on the central atom. And so this will be bent. Again, oxygen, hydrogen, hydrogen, and there it is. And again, it's bent because there's lone pairs. Now, remember I told you that if it's ASF5, if there's a 5 there, it's going to be trigonal bipyramidal, because tri plus bi is 5. Trigonal bipyramidal. And then if there's 6 on there, it's called octahedral. And someone might be asking themselves, well, why isn't it called hexahedral? Because there's 6 atoms on the central atom. Well, the reason why it's called octahedral is because if you were to look at the shape three-dimensionally and you were to connect a dot between, if you draw a line between all the atoms, it actually would make an 8-sided shape. And so if you Google octahedral, you'll see that it makes an 8-sided shape. So the summary here is, if there's 2 atoms on the central atom, it is either going to be linear or bent. All right, if there's, so if there's 2, it's either going to be linear or bent. If there's 2 atoms on the central atom. If there's 3 atoms on the central atom, it's going to be trigonal planar or trigonal pyramidal. If there's 4, it's going to be tetrahedral. Easy peasy, just tetrahedral. If there's 5, trigonal bipyramidal. And if there's 6, octahedral. And so really, you just have to be able to determine if there, what it is. If there's 2 atoms on the central atom, or if there's 3, you have 2 choices between each one. And that's it. And so those are the names of different shapes. Come to class with questions. Have a great day.